right, this is 4-6 in the Big Ideas book. We are doing page 214, 1 through 55 odd, and 33 through 38 all. It sounds like a lot, but many of these problems are very easy and quick to do. So some vocabulary for today is what is an arithmetic sequence, common difference, and the nth term. So the purpose of today is to look at arithmetic sequences and to find an equation to determine other numbers in that sequence. So for instance, if I'm looking for the millionth term in the sequence, instead of making a table and listing all the terms, I can use a formula to figure out the millionth term in a sequence. That is the purpose. All right, so in an arithmetic sequence, the difference between each pair of terms is the same. So it's numbers in a sequence, they're in a consecutive sequence, and their difference between them is the same. We call that difference the common difference. These numbers right here, these are called our terms, and this number right here, it's our common difference. Okay, so each term is found by adding the common difference. Yeah, sorry, I was trying to turn it off. All right, so can we figure out now how to write the next three terms in the arithmetic sequence? What would we do?
Subtract 7.
Subtract 7. So we're noticing that every time we are subtracting 7. Minus 7. Minus 7. So what is my common difference? Negative 7. So what would the next three be? Negative 35.
Negative 35, negative 42, negative 49.
So that's all we're doing. That's a lot of your problems for homework tonight, right? Kind of like elementary school, but now we're putting some vocabulary to it. So, finding the next three terms in an arithmetic sequence. We can use a table to organize. And what we do is we take terms in a sequence and we create, you can either do it vertically or horizontally, and we say this is the position number and this is the term. So position 1, the first position, the term is negative 7. Position 2, the second term is negative 14. Position 3, it's negative 21. Position 4, it's negative 28, and so on. Does everybody understand the idea of the position number and the term? So if they're given an arithmetic sequence, I can just put it into a table like this and add 1, 2, 3, 4, my position numbers. 1 means it's the first term. 2 means it's the second term. 3 means it's the fourth. Is everybody clear on that? And like I said, we add 7, and that's how we get our next three terms. Questions? All right. So the next three terms, if you were to answer, would be negative 35, negative 42, negative 49. All right, graphing an arithmetic sequence. Well, we said if we're given an arithmetic sequence, what can we do with it? Put it where? In a table. So if I put it in the table, what would be the first term? No, 1 is not the first term. 4. What is the second term? 8. Third term?
12.
Fourth term?
16.
Good. So we're going to make a table. Now, we call the position n. Okay? We're calling this n. And we call the term a sub n. Because I could say like a sub 50, that means the 50th term. Does that make sense? Or if I'm talking about, if I had something like this, a sub 2, that means the second term is 8. That's the n, and this is the a sub n. That's the whole thing. Okay, so we're going to call this n, and this one, the amount of the whole thing, a sub n. Okay, now we have something to plot. If I give them position numbers, I can go 1 over 4 up, 2 over 8 up, 3 over 12 up, and 4 over 16 up. Would I connect these points?
Yes.
I'm going to remind you, we are in an arithmetic sequence.
Oh,
That's
no,
it.
No.
It's not a linear equation. We're plotting an arithmetic sequence. Would I connect it?
No.
Because I'm not going to necessarily do 1.5. That's not in the sequence. I don't want the 1.5 term. I only want the first term, the second term, the third term. Okay, we don't want the data in between. So it is discrete. Okay, so the points lay, and notice in an arithmetic sequence, what shape does it make? A line. Okay, so it should make a line shape. So now, can you tell me, is this an arithmetic sequence?
Yeah.
Okay, we can tell a couple different ways. What's one way?
The difference
The
between
difference between them is the same.
and the line.
Okay, so number one, he says a line, and number two, he's saying right here, we have a common difference. What is it?
Subtract that.
3.
Subtract 3, subtract 3, subtract 3. Minus 3, minus 3, minus 3. Common difference here is plus 1, plus 1, plus 1. Both have a common difference. So we can see it there. We can also see that it's making a line shape. All right, we can make the table and organize it and then look at the common difference, but we kind of just did it right there. You can notice that right here it's going plus 3, plus negative 3. Actually, we're subtracting 3. It wasn't plus 3, it was minus 3. So when we're looking at arithmetic sequences, we're looking at adding or subtracting a common number. Because really, if it's subtracting, it's adding a common difference of a negative number. Does that make sense? All right. So the graph represents an arithmetic sequence. All right, so now we're going to go to, let's talk about our first term. I know it's kind of fuzzy here, but the first term, can we call it a sub 1? And then to get the next term, don't we add a difference? And then to get the third term, I'm adding another difference. 2 differences to the first term, right? And to get the third one, I'm adding 3 differences. So notice in the fourth term, I'm adding 3 differences. Does that make sense?
Yeah.
Okay, so we have this formula. It's the first term plus the term number minus 1, right? Isn't this minus 1? Isn't 2 the second difference minus 1 here? And this 1 difference minus 1 here? You guys with me?
Yeah.
So the way that the formula works is, I'm going to write it big for you to see. And I want you to write this down. It's a sub 1. It's the first term. So we're going to say a sub n, any term number, is equal to the first number plus the position minus 1 times the common difference. Where this stands for the first term, first term. And this represents the position. And this is the common difference. So does everybody understand why it's n minus 1?
Mm-hmm.
Yes, no?
Yeah.
Let me see thumbs. Yes, I understand. No, I don't. All right, can I move on?
Yep.
Okay. All right, so there's our formula. It says write an equation for the nth term of an arithmetic sequence. Okay, so before we go to the 50th term, they want us to do this in 2 parts. We can go right to the 50th part. I'll show you both ways. But let's write the equation. They want just the general equation. So, hold on, let me do this. just the general equation for the nth term. So a sub n, since it said the nth term. If they had said the 50th, so it's a sub n, and remember, what does a sub 1 stand for?
The first term.
What is it?
14.
14 plus, and then we don't know what term number. Right now we don't know, but we do know the common difference. What is it?
-3.
-3. Okay, and we simplify that. A sub n equals 14 plus, or actually we're going to have to distribute right here. Do you see that? Minus 3n plus 3. What does that simplify to?
17 plus 3. Minus 3n.
17 minus 3n. I'm going to put it in minus 3n plus 17. So now this is the arithmetic sequence equation for this sequence. Then direction number 2. So here's direction number 1. Here's direction number 2 that says then find a sub 50, the 50th term. So I'm going to write the 50th term equals, you should be writing, the equation is -3n plus 17. The 50th term equals -3 times 50 plus 17. The 50th term equals -150 minus 17 plus. When I distributed, because I combined my like terms here and here. Okay? And good question. Now I'm going to simplify, and we end up with a sub 50 equals -133. So what this means is the 50th term would be -133. Does that make sense?
Yeah.
Now, I could have gone right away. I could use this and do a sub 50 equals, the first term is 14, plus the term number is 50 minus 1 times -3. So I could have done a sub 50 equals 14 plus, and here I'm going to get 49 times -3. We have to multiply before we add. 14. What's 49? Oh, 147. Minus 147, and a sub 50 equals -133. So that's another way, but because of the directions, do you guys understand? It says write an equation, that's the first thing, and then it says then find. That's why I did it in 2 steps like this. Do you understand?
Yes.
Okay. All right, so let's continue. Write an equation for the nth term, so they're just doing that. We just did this. There's the equation, and now we put the 50th term in. Okay, online bidding for a purse increases by $5 each bid. After the $60 initial bid, write a function that represents the arithmetic sequence. Okay, so we're going to do a sub n. What would it look like, guys? Oops. A sub n equals, what's the first term? 60 plus, what am I doing? N minus 1. And do we know what the common difference is? 5. So it says yes.
I'm so confused on like why you do n minus 1.
Okay, because, hold on, I'm going to have to come back to that. Let me finish this. I have to go back a couple slides. So now I'm going to a sub n equals 60 plus 5n minus 5. So what does that simplify to, guys?
A sub n equals 5n plus 55.
5n plus 55. Okay, and now it says, so there's the function. Then we have to graph it. You guys with me?
Yeah.
I'm going to put the graph up because it'll be... Okay, then we're going to, we use the table and we're going to plot the amount. So 160, 265, 370, 475. I want everybody to notice the scale because this came up on the test. Notice I go from 0 to 55. Then the next line should be 55, right? But when you put this little break in, this means this is going to jump data. And then the scale is increasing by 5, by 5, by 5. Do you see that? I mean, normally, right now, if you don't put that break in and you jump to 55 and then do 67, 65, 70, it would be marked wrong. You would have to go 55, then another 55, then another 55. Does that make sense? Yeah. Okay. So is this, here it is right here. Now, the next part of that, we made the plot and we graphed it. And it says use the function to find the value for n. Well, our function equation was this, right? A sub n, but now we're just changing it to function notation. And what would I do with the 105? Because, let me go back to the problem. Okay, part C is the winning bid is $105. How many bids were there? What is that? Is that my X or is that my Y? That's a Y. So in the function notation, where am I putting that? Where do I put that into the general equation? For the f of n or just for the n?
For the f of n.
The f of n. We put 105 here equals 5n plus 55. We're subtracting 55. And we get 5n. And this becomes 0. Oh yeah, 50, sorry. Equals 5n divided by 5. And n is equal to 10. So is everybody understanding that part?
Yep.
There were 10 bids. So remember this was about bidder number and bid amount. So these were how many bids there were. I think, okay, that's really it from the book. So let's go back here. I think, actually, let's go into my PowerPoint because I think it might be clearer. I don't know if I have it here. No, I don't. Nope, I don't have it. Okay, so let's go back. Here. Okay, that's the lesson for today. I'm coming back because I'm re-explaining why it's n minus 1. So for the recording as well. So remember if I have, let's just say we have a table, right? And let's say it's 4, 7, 10, 13. Are you with me? Mm-hmm. Okay, so we could say this is the first one, right? And this would be the second one. And this is the third one. And this is the fourth one. We know that our common difference is what?
Oh, plus 3.
Plus 3. Plus 3. Plus 3. So in the first term, we call it a sub 1, right? So in the formula right here, that's the first term. The second term, isn't it the first term plus the common difference?
Yeah.
Right? Plus 3. So it's 4 plus 3, right? Mm-hmm. One common difference here. the second term. Isn't it the first term plus 3 plus 3? Right?
Yeah.
So 2 differences. Do you understand that so far? So notice in the third term, it's 2 differences that are added. That's why it's n, the term number, minus 1. Does that make sense? Okay. The third term is 1 less than the term number 4. So on the 59th term, I would use 59 minus 1, right? And then multiply it by, so 58 times 3. Does that make sense? Okay, that's how we got our n minus 1 in this formula. Okay, that's the lesson for today. That's it.